Lesson 53 is metric unit conversions, English units to metric units, and then weight combination by percent. Okay. Example 1. Use unit multipliers to convert 15,740,000 square centimeters to square kilometers. So this is all in the metric system. So centimeters to kilometers. We have square units. So we're going to talk today about kind of combining 2 unit multipliers that are squared into a single one. So we're going to start with what we're given, 15,740,000 square centimeters. So I need to go from small to big, centimeters to kilometers. So my in-between step is going to be meters. So centimeters to meters. Normally I would, since I have 2 centimeter units, normally I would write 2 unit multipliers, 1 meter, 100 centimeters. I would write 2 of them, correct? And that's important because when I go to cancel my units, like I like to do, I like to cancel my units as I go, I can cancel what I'm starting with, square centimeters. I have 2 of them. I cancel 2 units in my next step. And I see that leaves me with 2 meter units, which is metered squared. So follow along with me at the top. Instead of writing 1 meter over 100 centimeters twice, I'm going to write it once, and I'm going to take it to the second power. However, when I cancel my units, I'm only going to cancel down here. So square centimeters cancels this centimeter unit right down here, understanding that this is applied to this as well. I'm not going to cancel the 2 up here on the power. Why? Because I still need it. So let's uncross that. Look at the original in red down here. I still have 2 meter units, and I still have 2 100ths as factors. So I need to leave that 2 there. All right, so now I'm in meters. I need to go to kilometers. So I'm going to use my kilometers to meters unit multiplier, and I'm careful to line those up so that I have meters on the top and meters on the bottom so that they cancel. And again, I have square units, so I have to do square units again. Canceling my meters. And what units are we in? Let's take inventory. Kilometers. Great, that's what we needed. We're in square kilometers. So I'm ready to put all this in my calculator. So this is what I'll put in the calculator. In fact, this is what the back of the book is going to tell you. So we're going to go one step beyond. Now, I know you guys have done these problems before, but in Algebra 2, you're going to concentrate more on what your final answer looks like. When you pull that up in your calculator, let's take a look at the division template. So if I hit Control Divide right there, Control Divide, it brings up that fraction template so I can clearly see what goes in my numerator and what goes in my denominator. So that's really helpful. So let's put this in and see what we get. So we've got 100 squared, and so I can use my squared key. Okay, and then I have times 1,000. Square that again. Okay, so I'm ready to go. And when I hit enter, I get a fraction. Well, that's not okay. Okay, I don't want a fraction value. That's really meaningless. a fraction square kilometers, that's kind of meaningless. I need a decimal value. If I don't get a decimal, I can force it to give me a decimal for that fraction by hitting the Control Enter. Control Enter, notice it's that little squeakles symbol up there, which means approximate. Okay, and that gives me my decimal. Let's write that down and then discuss how we're going to express our answer. So this is nice. It actually terminates after the 4. So 0.001574 square kilometers. That's one choice if you want to just leave it as the full value, if it's not too many decimals. The other thing is we can round, we always round to 3 decimal places. I'm going to change that a little bit. If I round this to just the 3rd decimal place, that would round up to a 2, but 0.002 is not as accurate as I want it to be. I'm losing a little bit of exactness, if you will. Losing a little bit of precision if I do that. So if I have 2 or more, if I have 2 or more zeros after the decimal, I'm going to ask you guys to use 3. So not just 3 decimal places, but round to 3 significant figures. You should be learning about this in science. So if not, just real quick, a significant figure, we talk about that if we have lots of zeros, like after the decimal place. So if you have zeros in between the decimal and the other non-zero numbers, those zeros are not significant. So you want to get the non-zero numbers, digits, okay, after those zeros that are kind of taking up place after the decimal. So take a look at my original answer here. I would go to that 3rd significant figure, which is the 7, right? The 1, the 5, the 7, those are significant. I'm going to round to that place right there. So I'm going to cross that off, and I'm going to say instead it's 0.0015, and then rounding to this next position, it doesn't round up, so I keep it as a 7. That is more preferable, okay? Or you can do scientific notation. If you do scientific notation, I would like 3 decimal places after the decimal. It just so happens that that's what this one gives us. Okay, but those are your options, okay? Option number 1 is to leave it as the full unrounded value if it's not too many digits, right? Or round to 3 significant figures, or use scientific notation. Let's do another one. Use unit multipliers to convert 32 yards to meters. This is one in which we're going from English to metric. And when we do that, we need a link. Okay, we need a link, and that link is 2.54 centimeters equals 1 inch. Okay, that's going to help us jump from English to metric and vice versa. Okay, that is our link. I can write it two different ways, but let's see what we have. 32 yards is what we're starting with. I'm going to go like this. So yards to meters, okay, with a side trip in between. I first have to go yards to, look at your link. What's the English unit there? It's inches. So I have to go yards to inches first. Okay, so that's what I'm doing here. Cross off your yards. Great, now you're in inches. Once you're in inches, you can use that link. That link is the 1 inch is 2.54 centimeters. And once you do that, making sure to line up one on the top, one on the bottom, whatever you want to cancel. So 2.54 centimeters on the top. Now, all of a sudden, you're in metric. Okay, so that's good. We're not in English anymore. Now we're in metric, and we can go back up now from centimeters, make our way up to meters. So we'll do centimeters to meters, making sure we cancel centimeters, one on the top, one on the bottom, and then meters. Oh yeah, meters, then we're there. We're going to pull this up in our calculator because that's partly what this lesson is about. So I want to go Control Divide. And when I put in my values in the numerator, notice I have 2.54. That already has a decimal in it. So if I have a decimal anywhere in that template, my answer is going to be in decimal form. It forces that. So 29.2608 meters. And since that ends at the fourth place, I honestly wouldn't go ahead and round that. I would just leave it. But I mean, you certainly could round it to 3 decimal places, but there's really only one more digit, so it's not that big a deal. But again, I'm giving you choices here. Okay. Let's talk about percent by weight. These are problems that you have done before. Okay. You've figured out how much is sodium, how much is oxygen, whatever, of the final solution. This is what's different. What percent by weight? So you're going to set these up as normal. So you've got 2 sodiums, 2 sulfurs, 3 oxygens. You've got your table here. And then, of course, you have your total. So you're going to write the total formula here, Na2S2O3. So keep in mind, this is your total. Here's the new part. I know you know how to fill out that middle part, but this is the new part, is you're going to have a percent column, all right? Where do you think the 100% goes? Hopefully on the total, yes? So the 100% is the total solution. What's it asking you to do in the problem? What percent by weight is sodium, which is the Na? So your X is going to go here, okay? What percent by weight? So let's finish filling this out. We've got 2 sodiums, 2 Nas, 2 times 23, 46. We've got 2 S's, so 2 times 32, 64, and we have 3 O's. 3 times 16 is 48. Great, so when I add all those up, one molecule is 158. Okay. We could actually find the percent by weight of any of these substances, but they just ask in particular for the sodium. So we're done with this row, done with this row. And we can go ahead and cross multiply. So 158x equals 46 times 100. And you're going to put all this in your calculator anyway, I assume. Right? So putting that in the calculator, 29.114. And since we assume that our setup is already in percent, this number is a percent, right? X, where we put the X, that's a percent. So when we do it that way, we don't have to convert a decimal to percent. The other way you can do this real quick is, you can get rid of this percent column, and then you can just go, all right, sodium over the total, you can do it like that. Sodium is 46 out of a total of 158, and you would get that. That's going to be a decimal, isn't it? Okay, that's going to be 0.029114, but then you have to convert to a percent, right? This is just a pure 46 out of 158 is this. Well, what percent is that? Move the decimal. Oh, sorry, I got that a little wrong. That should be a 0.29. Excuse me on that. 0.29. All right, then you'd have to move the decimal to the right and call it a percent. And you could do that with any of the substances. The beauty of setting up this third column this way is that it's already understood that all of my numbers here are in percent already, okay? And so that's percent by weight, and we are done. So